Good morning and Sairam to all. In previous video, we have started our chapter 4th of physics, that is work, energy and power. And we have already finished our work part. So in this video, we are going to start our energy part. Before going to start today's lecture, what we will do a quick revision what we have learned in our previous video. So in previous video we have done what is work. Basically work means what? A physical or mental activity. So but in a physics language, our work is done when there is some displacement, when you applied force. Clear? In the terms of physics, what do you mean by work? Work is said to be done when you applied force to any object and it displays in the direction of force applied. Clear? And the formula of work is W is equal to F into S. W is equal to F into S, where your W stands for work, F stands for force and your S stands for displacement, where your W stands for work, F stands for force and S stands for displacement. And if we are talking about SI unit of work, it is what? It is joule. Basically it is Nm, but Nm is equal to joule. So 1 joule is equal to 1 Nm. And your work, it is represented by capital J. Clear? It's SI unit, so it's a scalar quantity. Work is a scalar quantity. If anything is a scalar quantity, what it indicates? Tell me fast. What it indicates? It indicates that we will only consider magnitude. We will only consider magnitude. We will not bother about the direction. We will not bother about the direction. Is this clear? And what is the formula of work against gravity? What is the formula of work against gravity? The formula is W is equal to mgh. The formula is W is equal to mgh, where your W stands for work done, m stands for mass of the body, g stands for acceleration due to gravity, and h stands for height through which the body is lifted. Is this clear? What is the formula of work done against gravity? The formula is W is equal to mgh. W is equal to mgh. Clear? So let us start today's lecture, and our topic is energy. And our topic is energy. So first I will do a quick review about energy. Basically your energy is defined as capacity to do work. Basically your energy is defined as capacity to do work. Clear? So hey, basically your energy is basically your work is dependent on energy. So the SI unit of energy is also joule. Clear? Now there are many forms of energy. Some are kinetic, potential, electrical, chemical, solar and nuclear. Is this clear? So with this, listen, see, if a person can do lot of work, we say that he has lot of energy. Or in a simple language, you can say that that person is very energetic. Clear? So in physics also, in the terms of physics, anything which is able to do work is said to possess energy. If anything which are doing some work, that means that object possess some energy. So with this we defined as energy. So we define as energy the amount of energy possessed by a body is equal to the amount of work. Basically the amount of energy possessed by a body is equal to the amount of work. it can do when its energy released. So this is the definition of energy. What is the definition of energy? The amount of energy possessed by a body, the amount of energy possessed by a body is the equal to the amount of work it can do when its energy is released. Basically, your energy is a scalar quantity. And what is the SI unit of energy? The SI unit of energy is joule. It is joule, and it is denoted by capital J. What do you mean by 1 joule? So the energy required to do 1 joule of work. The energy required to do 1 joule of a work is called 1 joule energy. And 1 kilojoule is equal to 1000 joule. 1 kilojoule is equal to 1000 joule. I am reading this slide once more. The amount of energy possessed by a body is equal to the amount of work it can do when its energy released. So with this, we can say that whenever work is done, in that case some energy is consumed. Whenever work is done, in that case some energy is consumed. Second point is energy is a scalar quantity. So in this case also we will consider only magnitude. What we will consider? We will consider only magnitude. We will not consider direction. SI unit of energy is joule. SI unit of energy is joule. And the energy required to do 1 joule of work is called 1 joule energy. The energy required to do 1 joule of work is called 1 joule energy. 1 kilojoule is equal to 1000 joule. 1 kilojoule is equal to 1000 joule. Is this clear? Now, different forms of energy. Energy exists in many forms. The main forms of energy are: number 1, kinetic energy; number 2, potential energy; number 3, chemical energy; number 4, heat energy; number 5, light energy; number 6, sound energy; number 7, electrical energy; number 8, nuclear energy. So, in 8 forms the energy exists: kinetic, potential, chemical, heat, light, sound, electrical and nuclear. In your syllabus, basically 2 types of energies are there: kinetic and potential. So we will go deeply about these 2 energies. Let us start with the kinetic energy. Basically, we know that, what do you mean by kinetic energy? The energy which produced due to the motion. The energy which produced due to the motion is known as your kinetic energy. Clear? For example, a moving cricket ball can do work in pushing back the stump. Moving water can do work in turning a turbine for generating electricity. Clear? Thus, moving body is capable of doing work. Moving body is capable of doing some work. And I told you that if any object doing some work, that means that object possesses some type of energy. Clear? And if energy which produced due to the motion, that type of energy is known as your kinetic energy. That type of energy is known as kinetic energy. So basically, the energy of a body due to its motion is called as your kinetic energy. Example: moving cricket ball possesses kinetic energy. Runners possess kinetic energy. Running motorcycle possesses kinetic energy. So these all are the example of kinetic energy. Clear? If we are talking about the formula is Ke is equal to half mv square. Clear? Ke is equal to half mv square, and SI unit is joule. SI unit is joule. So see here, this is a car. See, car having mass m of F1. Clear? In kg, mass is in kg. Now velocity increases, so kinetic energy also increase. So basically your kinetic energy is energy produced due to the motion. Energy produced due to the motion. Is this clear? Now formula for kinetic energy. Our next topic is formula for kinetic energy. The kinetic energy of a moving body is measured by the amount of work it can do before coming to rest. Clear? How you will calculate the kinetic energy? The kinetic energy of a moving body is measured by the amount of work it can do before coming to rest. Clear? That means if you want to calculate kinetic energy, you have to calculate before that object comes to rest. After rest, you can't calculate the kinetic energy. Why? Because kinetic energy produced due to the motion. If motion is stopped, how you will calculate? Is this clear? So now just see this figure. Suppose a body is such a ball of mass m. Clear? And moving with the velocity v is at position A here. Now let enter into a medium m. This is your medium m and this is air. Medium is air, which opposes the motion of the body with a constant force F. That means that balls want to come in this side, but this medium opposes the motion. So the force act will on this side. As a result of the opposing force, the body will be constantly retarded. That is, its velocity decreases gradually, and it will come to rest or stop at a position B here. After traveling a distance S. So the final velocity v of the body becomes 0. Why its final velocity becomes 0? Because that object comes at rest. I told you, if the final position is rest, in that case the final velocity will be 0. Clear? So I am reading this once more. Suppose a body such as a ball of mass m moving with a velocity v is at A. Let it enter into a medium m, such as air, which opposes the motion of the body with a constant force F. As a result of the opposing force, the body will be constantly retarded. That is, its velocity decreases gradually, and it will come to rest or stop at position B after traveling a distance S. So the final velocity v of the body becomes 0. Becomes 0. So in going through distance S against the opposing force F, the body has done some work, and this work is given by W is equal to F into S. W is equal to F into S. At position B, the body is at rest. That is, it has no motion. If there is no motion, that means no kinetic energy. This means that all the kinetic energy of the body has been used up in doing the work. So the kinetic energy must be equal to W or W is equal to F into S. Clear is this? Now if a body is initial velocity v and final velocity v, acceleration a and travels distance s, then according to the third equation of motion, your v square is equal to initial velocity plus 2as. Here your initial velocity is small v. So you will write this. In the above example, we have noted that initial velocity is v and final velocity is 0 because it will come at rest. Acceleration is minus a. Why? Because here retardation is taking place. That force which you are the force which is acting, it is in a opposite direction. So in this case, your in that case acceleration is not take place. What is taking place? Retardation is taking place. So in the case of retardation, we always take acceleration in a negative. So now putting this value in the above equation, so what we will get? We will get v square is equal to 2as. What we will get? We will get v square is equal to 2as. So from the Newton's second law of motion, F is equal to ma. F is equal to ma. So a is equal to F upon m. Just put this value of a over here. Just put the value of a over here. So you will get v square is equal to 2 into F into S upon m. Clear? So this m will go here. So it will become v square F into S is equal to 1 to mv square, and this Fs is equal to what? This Fs is equal to it. This F, what we have got? We have got F into S is equal to half mv square, and this Fs is equal to W, and in earlier we have done W is equal to Ke. So last you will get Ke is equal to half mv square. Clear? I think this is clear to you. Now some important conclusion. If the mass of a body is doubled, its kinetic energy also get doubled. Its kinetic energy also get doubled, and if the mass of a body is halved, its kinetic energy also get halved. Now, if velocity is double, kinetic energy becomes 4 times, and if the velocity of a body is half, its kinetic energy becomes 1/4. Since the kinetic energy of a body depends on the mass and velocity. Is this clear? Now we will do some numerical. You have to calculate the kinetic energy of a body of a mass 2 kg. Mass is 2 kg and velocity is 0.1. Mass is 2 kg and velocity is 0.1. So kinetic energy is half mv square. Half into 2 into 0.1 into 0.1. 2 से 2 cancel हो जाएगा. What you will get? You will get 0.01 joule. So in this case, the kinetic energy of a body is, 0.01 joule. 0.01 joule. Is this clear? Now, second question. Two bodies of equal masses move with a uniform velocity v and 3v respectively. find the ratio of their kinetic energy. Clear? So in this problem, basically the mass of two bodies are equal. So let the mass of each body be m. Clear? And velocity of the first body is, now the m is velocity of first body is small v. So kinetic energy of first body is half mv square. Clear? In the second body, the mass will be same m, but the velocity is 3v. So half into m into 3v का square. 3v का square will become 9v का square. So 9 by 2 mv का square. So the kinetic energy of first body is half mv square, and kinetic energy of the second body is 9 by 2 mv square. Clear? Now what you have to do, you have to find the ratio. So first body upon second body, half mv square upon 9 by 2 mv square. So this will become half into 2 by 9 mv square. mv square will cancel, 2 will cancel. So the ratio is 1:9. Clear? So when, is this clear? So when the velocity of a body is tripled, then its kinetic energy becomes 9 times. Clear? Now a 624 kg of F1 car is moving at a speed of 150 km per hour. Determine the kinetic energy of the car. Mass is given to you, speed is given to you. Just put and get the answer. This is in kilometer per hour. You have to convert into meter per second. Clear? So you will get 14.167 as a speed. So this is your basically, if you will convert speed kilometer per hour into speed, you will get 14.167. Just put the answer, just put the value and get the answer. Our next topic is potential energy. Our next topic is potential energy. So suppose a brick is lying on the ground. A brick is lying on the ground. It has no energy, so it cannot do any work. Let us lift the brick to the roof of a house. Now some work has done in lifting this brick against the force of gravity. So this work gets stored up in the brick in the form of potential energy. So basically, what do you mean by potential energy? Potential energy is an energy possessed by an object. Potential energy is an energy possessed by an object due to its position of state. Due to its position of state. So your PE is equal to mgh. Clear? Your PE is equal to mgh, and SI unit is joule, where your m is mass, g is gravitational acceleration, and h is height. In this picture, the cat has potential energy at a high position. Is this clear? What do you mean by potential energy? Potential energy is possessed by an object due to its position or a state. Its formula is P is equal to mgh, and its SI unit is joule. A load with a mass 5 kg was lifted up by a pulley to the height of 0.8 meter for pile work. G is given to you 9.81 meter per second. You have to find out potential energy. So your PE is equal to mgh. The value is m is 5. The value of G is 9.81. The value of H is 0.8. So the answer will be 39.24 joule. Is this clear? The next one. If acceleration due to gravity is 10 meter per second, what will be the potential energy of a body of mass 1 kg kept at a height of 5? mgh formula is clear. The value of m is 1 kg, acceleration due to gravity is 10, height is 5, and potential energy, you know that P is equal to mgh. So 1 into 10 into 5 is equal to 50 joules. Clear? The last one is a bag of wheat weighs 200 kg, height raised to this, you have to find h. P is given to you 9800 joule, m is given to you 200 kg, g is given to you 9.8. so it is mgh. P is equal to m is given to you, g is given to you, p is given to you. Just put the value and get the answer. So h will be 5 meter. Clear? So with this, kinetic energy and potential energy topic is finished. I think each and everything is clear to you. Thank you and Sairam.